Hi, in this video, we're going to be looking at the properties and applications of logarithms. So first of all, we're going to review some of our basic properties here, and we're going to be using the definition which says that if we have a base a to the y equal x, we can rewrite that as log base a, so the same base, of x is equal to y, where we remember that whatever log equals y is that exponent. So we can use those rules to help us compute some simple logs that we will be using along the way. You might remember from graphing, if we have log of any base of 1, that special point gives us 0. The reason being, if we use this definition, we can say that, all right, log base a of 1 is equal to blank. So the blank would be x, that's going to be the exponent. And then a is going to be our base, and that's equal to 1. So any base to what power is equal to 1? Well, it's 0. So log of any base of 1 is 0. We can similarly say that if we have the same base as what we're taking the log of, we will get 1 back. Let's go ahead and write that using our definition here. So log base a of the answer x is equal to a. So that would be a to the first is equal to a. So if you take log base a of a, or log base 10 of 10, remember log by itself is just log base 10, or log base e of e, you're going to get 1. Okay, now let's say that we raise that a to a power. So this is an inverse rule. If we have log base a of a to the x, this is actually the inverse function of log base a of x. If we wanted to call this output y, we could say by our rule, base a to the y is equal to a to the x, and then that y would equal the exponent x. So whenever we take a log of a certain base of that exponential function with the same base, we get the exponent back. All these cases, we get x. Logs are also one-to-one functions. So all logs are one-to-one, which means that when we have two of the same logs equal to each other, so here's two log base a's, then their inputs are going to be equal to each other. So when the y values are equal to each other, since logs are one-to-one, their inputs are going to be equal to each other. So log base 10 of x equal to log base 10 of y would mean x is equal to y, and natural log of x equals natural log of y implies that x is equal to y in here. So if we have log with the same base, we just set those inputs equal to each other. Finally, we have an inverse rule that's very similar to the one that we have up here, but now we're taking a to the log base a. I know that that's pretty small. Let me go ahead and see if I can get it even better in focus here. There we go. We're getting better there. So if I have a to the log base a of x, the a and the log base a cancel out. They just give me x back. 10 to the log base 10 of x, I get x back. E to the log base e of x, I get x back. And again, you can go ahead and turn these into these exponentials into logs and show that that's true. We'll be looking at more of these rules when we come back.